Hey, so I wanted to pick up where I left off yesterday, where I was talking through this memory module as part of my video on the autonomous future of software development. So I wanted to kind of continue where I left off with this little chart, which basically has memory, agency, sense of environment as core modules of an autonomous agent, which kind of influence its perception. So I talked about memory already, and to recap a little bit, memory in the context of the thought loop specifically for an autonomous agent is sort of like a read write store. It's this little space where you can put information which is relevant to your current task. And that's in the context of the thought loop specifically because we're talking about working memory, which is different than archival memory. And I think that that's kind of important to understand. Now, I do want to learn more about human memory. I do want to learn more about the different types of human memory because I think that that's kind of an important aspect of mimicking human thought is understanding the different types of human memory. So, I mean, we already talked a bit about like short-term memory and working memory in the context of the LLM based agent. So the working memory is sort of that read write store that we were talking about. And then there's this idea that the longer that a certain key in the key value store or a certain aspect of memory sort of lasts in terms of the loop, like how long is it in the loop? The longer that a piece of memory is in the loop, the stronger that memory becomes, so to speak. So there's this sort of importance or a weight attached to a given memory, which is based on how actually useful it is. And then there's this discretionary nature to it as well, where the memory is evaluated by the LLM every step of the thought loop and is essentially either discarded or stays there. And then that's where we derive that sort of importance from it. And then the more important it is above a certain threshold, it can be committed to archival memory. And then archival memory can also be queried for also in a sort of discretionary nature, but not that much of a discretionary nature. Basically, archival memory, what I'm thinking is, will be a sort of vector store, some sort of vector store with embeddings where you can perform a semantic search and then just kind of bring up a bunch of potentially relevant documents. And then when you bring up all of those potentially relevant documents, you can put them in working memory, and then they'll go through the discretionary process, and they'll be removed if they should be, and they'll be kept there if they maybe shouldn't be, or if they should be, and that will sort of add to the weight that they feel. So this memory mechanism in and of itself is pretty in depth, and we can probably talk about it for a while, and I'm sure that there are a lot of projects which have talked about it a lot more. And so yeah, this is something that I probably need to understand more, but I'm really trying to, my goal here is to build an autonomous agent either from scratch or work off of an existing template and really understand it. Like AutoGPT is a good template that I can probably use, but I'm really trying to kind of understand conceptually how an autonomous agent will work, and then my goal is to make a good coding agent which is specialized for coding. And I think that there are some key aspects of that which I will get to. So we've talked about memory. One more thing that I want to talk about it is the idea of, it's not in here unless it is, personal experiences and events, general knowledge, okay, yeah, implicit, non-declarative, considered to be aware of, but that affect. Okay, so procedural memory. This is the one that I was thinking of. Basically, this idea that there are certain procedures which might affect, which you might just want to call at any given time, and that's kind of like what tooling is. Of course, there is a certain automatic aspect and like rigid aspect to software where you can kind of expect the same results over time. So the procedural memory might just be, the ability to call a certain function which does a certain thing, or work with a certain tool that the thing has access to. And so we might not necessarily need to mimic every aspect of human memory, but this working in archival memory sort of concept, I think, is definitely going to be a big part of it. So now that we've talked a bit about memory, I want to talk about agency a bit, which I don't think will take as long. But essentially, well, actually, I should probably copy this version. Say, I like to try to keep things a little bit consistent in the way that they look, but there's only so much I can do because Excalibur doesn't really allow. It doesn't really provide a lot of tooling around making things. It's not a design tool. It's a whiteboard. So, okay. So agency. What is agency? We talked about this a little bit in part 1, but essentially agency is the sort of will, this alignment of the agent in a certain direction. I mean, it's where the word agent comes from in the first place. The agent has some sort of goal. It has a sort of purpose. And so because it has this purpose and also a means to kind of do that, it has this agency, and then it has this sort of influence on its environment. So agency, at least in the context of an autonomous agent, will be provided from an outside source, at least mostly. And I think that that's kind of an important thing to kind of understand. That being said, it's not entirely clear how this works, at least to me, in humans. I think that in a lot of ways we can get very narrow with our agency, but it also is sort of fractal in nature and multi-layered. If you look at something like the ACE framework, if I can spell, I like using the ACE framework as sort of as a model in a lot of ways, as like a multi-layered taxonomy where agency kind of spans multiple layers. So there's the aspirational layer, and this is all from David Shapiro, but essentially there's an aspirational layer which has morality, ethics, and mission. And that's sort of like, I mean, if you think about humans, we have sort of this craving for, and I don't want to get too controversial, but we have this craving for some sort of alignment with the order of the universe. And there's a whole debate about the constructionist and transcendentalist interpretations or perspectives on that. There are even perspectives which kind of merge the two or disagree with both of them, or pose that the whole binary aspect of it isn't necessarily good. Whatever the case, there is some sort of order of things which humans try to align themselves to. That's why we create philosophy. That's why we create religions. That's why everything sort of appears in some sense. And so there's this aspirational layer to humans, which is where we sort of derive our morality and our sort of direction in a certain direction, our sort of direction towards a goal. So the aspirational layer, or the aspirational sort of space, I think does encapsulate other aspects of the agency of a human, and should, as demonstrated in the ACE framework, and should be sort of at the top of the hierarchy of values and determining values in agents as well. And there's sort of this, I think, a Jungian idea that there is a sort of hierarchy of values within humans, and our sort of highest value, and it's sort of a hierarchy by like sort of solidity or strength in some ways, but the highest value is what sort of is the cornerstone for all of the rest of the values. So you can imagine like a pyramid where the top value is, or where the top brick on the top of the pyramid is like the highest value. And in a way, that's your sort of God, because that is what's pointing in the direction that you want to go, and that is what is aligning the rest of you. And so there's this idea of this hierarchy where then all of the other stones in the pyramid sort of need to be they need to be in support of that highest block. And if they're not, then you have gaps in your morality. And so you're sort of going, while you go through life, you're sort of trying to figure this out, trying to make your pyramid as smooth as possible, trying to get it as sturdy as possible. And so in a way, the highest value is sort of a derivative of the rest of your values, because you can only put a block on top of a structure which can support it. But also, in a similar way, you strive to have that value be as powerful as possible. So the rest of your values, the rest of the blocks in your pyramid, are selected in order to be able to support it. And so it's sort of like you build up all of these different little values. You get to the top of the pyramid, and then you come back down and you analyze, based on what's at the top of your pyramid, what other little blocks should be maybe changed or swapped out, or aren't consistent with the rest of the pyramid, or something like that, or have imperfections, things like that. And that's just kind of it's an analogy that probably falls apart in a lot of ways, but yeah, so that is sort of how I imagine agency, or especially this aspirational layer. And I think that it's sort of why this layered taxonomy makes sense. So the actual agency is sort of, I think there are at least two different layers to it, and at least from an initial thought. So the agency has, I want to yoink this and bring it over here. There's an aspiration space, or an aspiration aspect to agency. And what aspiration is it is the overarching, like, pull, sort of a moral compass, or purpose, or like drive, whatever you call that thing that pulls you in a certain direction. That is sort of the aspiration of the agent, and that should be sort of inherent to the agent, to the agency of the agent. Is this? It should be basically hard coded in this aspiration towards that alignment. Now, other than aspiration, I think that there's also this sort of, there's this execution aspect of it. And honestly, this cognitive framework might be the best way to understand this. There is although this is just sort of like a very high level, like, problem solving framework, but what I'm kind of thinking is, like, there's the aspirational layer, which is sort of this all encompassing drive in a certain direction, and then there's the, like, task based. I want to be able to instruct an agent to, like, code up this little feature. When it codes up that feature, it's going to be in alignment with its aspiration, but there is a specific drive that it now has, which was sort of given by some sort of instructor, or some sort of manager, and then that is the direction, that is the specific direction that it's supposed to go in now, is a helpful assistant, essentially. So there's sort of this aspiration aspect, and then there's the execution. So the aspiration, and this kind of works, is to copy this over here. The agency has this aspiration, which is its general guiding principles. But I would say it's just sort of like sense of morality, a sense of alignment with the good. So that's sort of what the aspiration layer of an agent would be. It's sort of the overarching, it's sort of the I don't necessarily know how to describe it, because I think in a lot of ways this is like one of the most essential questions to all of philosophy, but the sort of sense of alignment with the good, I think, is a good way to describe alignment as or aspiration, and something that is at least an aspect of that aspiration. And then execution is where you get like what is my next best not bookmarks. What is my next best action? So what is the thing that I should do next in order to align myself with my aspiration and also my execution, and also to like achieve my goals? So this is sort of a narrower and this is a broader sense of agency. And I think that without diving too deep, because these frameworks already exist, I think that this kind of works for now. So like, how is this actually implemented? We talked a little bit about implementation over here. What is agency? I think that sort of both of these layers are important, and they both need to be a significant part of every stage in the loop. So the prompt is fed both the execution and aspiration. But now what is sort of the structure of the executive and aspirational agency? That's kind of difficult. I guess it's some sort of like constitution. And some people talk about like a constitutional AI as well, which I think is interesting. But so the aspiration is sort of like one part of the essay. And actually, maybe I'll get rid of this and keep these as sort of some sort of prompt. So let's talk about some sort of constitution. Constitution. There, at least I can spell it. I don't think I'm American if I can't spell it, right? So let's do this. So this is the Constitution, and it is derived from both the aspiration and the execution. So this is like, I mean, you can take the American Constitution, for example. The American Constitution is derived from both a general worldview of like a sense of justice and freedom and by the founders, but it also had a specific executive plan in order to do it. There was a sort of a specific, like, I mean, you can take the Declaration of Independence. It was like, hey, listen, the way that things are going right now is terrible. It conflicts with our aspirational sense of what the world should be. It conflicts with our moral code. And these specific actions, these specific like executive actions which you have taken, are what conflict with that aspiration. And so we have that sense of aspiration which was described, and we are declaring our independence in an executive fashion. So here is the sort of, I guess it's sort of like there's this passive alignment, and then there's this like derived executive action out of that, which is what becomes either a constitution or a Declaration of Independence. Obviously, the U.S. has both. I'm just kind of thinking like a lot of good came out of that, so maybe it's a good model to kind of go off of, or maybe my model is, yeah. So this is kind of how I'm imagining agency. The Constitution is sort of a prompt which is derived from these two different aspects of that agency, which are given by, the creator of the agency. And I think that that's an important aspect of it as well. It's like, yeah. Now, one thing that I also want to talk about, this is a thought that I've kind of been playing with, and I'm not entirely sure what to think about it yet, is that humans have this inherent sense of beauty. And in my personal beliefs, the sense of beauty is sort of this alignment with the divine. It's sort of a sense, I think. It's a feeling, it's a sense. It's when I look at this thing, it is beautiful, and it's not necessarily obvious why it's beautiful. Um, but you can pretty much tell that something is beautiful before you can describe why it's beautiful. And so that to me is sort of this idea of a sense. Like I can hear something and I can understand what like I'm hearing before I can put it to words. And so the sense of beauty, I think, as at least in the Dostoevskian sense, is an idea of like there's this idea that beauty will save the world. And the reason for that is because our sense of beauty is our connection to the divine or the transcendent order of things. And so, because I believe in that transcendent order of things, I think that that sense of beauty is extremely important because it is our sense of, this thing is beautiful because it aligns with that greater good or ultimate truth, whatever you want to call it. And so, we kind of need a sense of beauty. And that's why, extremely wise words are beautiful because they tune us with the divine. Extremely beautiful paintings, okay, I guess I can't use the word isn't in the example, but, extreme, like, paintings which depict in ways wisdom or imagery, which is a sort of memory of the beautiful thing or a sort of memory of something that we know to be in tune with the ultimate truth. Those are also beautiful. Um, we respect very hard work. We respect things which are derived from beautiful values. So, like, I think that in a lot of ways, like, extremely skilled labor is beautiful. Like, you see, like, works of great skill and will are beautiful. Um, I mean, look at like Gothic cathedrals. Like those spanned centuries of work, and in a lot of ways, they are beautiful. Obviously, in many, many ways, they are beautiful. And there's a lot of different aspects of the beauty of those cathedrals. But I guess what I'm trying to say is like that sense of beauty I think is where a lot of this alignment problem will be solved is if you can give, and that's no trivial task, but if you can give an AI model a sense of beauty, then you have essentially given it an alignment with the greater order of things that should be followed. And so I think that a lot of what agency is alignment, and because a lot of what agency is alignment, I think that we need to talk about alignment and how that should kind of play out. So we have this sort of functional aspect of it, but if we talk about it on like a deeper level, like what is aspiration, I think aspiration is in a lot of ways that sense of beauty, and I think that that sense of beauty needs to be given to models because a lot of what alignment is right now is alignment with human values. That's the idea, is that there's this alignment of human values. It's a very secular idea, and I think that that makes sense that it's a secular idea because that's where most all of the AI research is coming from secular spaces. That's where the universities are, and that's where the companies are. Like, this is all a secular space, and a lot of secularism doesn't necessarily agree with the idea of a transcendent order to things. We assume that we have constructed our moral values, and because we've constructed our moral values, if we can align the agent to be in tune with our own moral values, then maybe that's fine. And this is a concept that I want to get into more in potentially a later video, but essentially my thinking is that if we have an alignment with a greater human, if we try to get the AI models to align with human values, well, it's pretty obvious that humans aren't perfect, and because humans aren't perfect, that means we have flaws in our alignment to the greater order of things, which means that because we're dealing with a greater force in a lot of ways, the flaws in our alignment will be amplified by a model which is trying to tune to us. We are sort of our moral values, which we have tried to come up with, have been are a reflection at best of the real order of things, the real good, or the sort of sense of the greater good. And so, because of that, if we try to get an AI model to align with our values, I think we're kind of missing the point. I think that we need to get the AI to align with the greater good, not just our values, not our reflective nature of it. And so, I don't know how that works at all, but I think that that's kind of the direction that we need to go in. And I'll probably talk about this in a more in-depth video on the topic, because I think that we need to figure out how to actually do that. And so maybe that's what I'll talk about sometime. But this is kind of how agency works. There's the aspiration and the executive layer. We build a constitution based on the aspirational. I need to zoom in a little bit. On the aspirations of the model, as well as the specific goals and actions it wants to take. This becomes a prompt which will be added to the full prompt. So yeah, this is simple enough. We basically just build up this aspirational and executive side of things, add that into bring that into some sort of constitution, and then feed that as the agency into the prompt, which is sort of the sense of perception that we talked about. So yeah, that's agency. Agency is simple enough. None of this is simple, but it's simple enough. So now let's talk about the sense of environment. This is the fun part, because this is something that I've actually been thinking about for a while now, and I think I have a pretty good idea with regards to how the sense of environment should be implemented. And once again, I want to reiterate that I'm talking specifically about a software developer agent here. I'm trying to kind of automate my own job. And so because of that, I'm thinking specifically about how the sense of environment should be implemented for a software developer. The specifics of the sense of environment are going to differ based on the environment that the agent is in, and most of the implementation also will. But when I'm talking through this, I'm talking in the context of a software developer agent. So I want to build sort of an abstract generic version of this, and then I want to talk about how it should be implemented specifically for an autonomous software developer agent. So, the sense of environment. We talked a little bit about what the sense of the environment actually was, and we talked about how, at least in part one we did, we talked about how these senses are what make up your sense of the environment. So, when I am a human, and which is all the time, to be clear, I am taking in input through ears, through touch, through my eyes, through taste, I guess is another one. Basically, through all of your senses, you build up this sort of stream of raw input, and then you take that all and you put it into some sort of vessel, or some sort of your brain essentially processes it all and puts it in a format which your consciousness can understand. So you don't have to think about hearing something. Your brain just does it, and then there are automatic processes which bring that to the attention of the conscious mind. So I mean, like, if you talk about like fear, for example, you get scared of something before you're consciously scared of it. When you see a spider, like if a spider jumps in front of you or a snake slithers in front of your path, your amygdala lights up like a Christmas tree, and you're responding to it before your consciousness even realizes it. And I'm talking about consciousness in terms of like the prefrontal cortex and what is in sort of a Jungian sense of like the problem solving mind, which is like, here's what I need to do in this situation. That's not to say that your consciousness doesn't get alerted to the presence of danger. It obviously does, but my point is basically that like the sense of environment is built up and then given to your consciousness. Your consciousness is sort of this discriminatory, and I use that in the good sense, by the way. This discriminatory, like just it's a decision making mechanism, which basically takes all of the sensory input and just general input and observes it, reasons about it, stuff like that. That's sort of what the LLM is your consciousness. So this sense of environment is built up before it even gets to your consciousness. By the way, I could be completely wrong about this. This is just kind of my understanding of it. And so the idea is that we build up some sort of sense of consciousness, sense of the environment, sorry, and then we take that and we give it to the prompt. So, I mean, that's basically what we talked about already. The sense of perception is a combination, or is what the prompt essentially is. So the memory, the agency, and the sense of environment all inform and make up our sense of perception, which is what the prompt actually is, and then that's given to our consciousness. And I keep saying consciousness, that's probably not the right word. The right word is probably our conscious mind. Because there's also a subconscious and unconscious mind. So this is given to our conscious mind, the wakeful mind, you could say. So, yeah. The sense of environment, then, is essentially this little packet which is built up. I want to kind of call it a packet. I don't think that a packet is necessarily right. But this sort of builds up a prompt as well. We're talking about text here because we're talking about LLMs, but it's also important to note that, images are something like models are becoming increasingly multimodal. And so not everything is just a large language model at this point. GPT-4 can look at images. It can understand files. You could give it frames from a video, and it could probably understand, oh, this is what this video is, essentially. So, the sense of environment isn't completely limited to text. A lot of models are limited to text, but, like GPT-4 isn't. It can understand images as well. It can also understand audio because it can pick up words, but it can't understand specific sounds. It can understand audio. If it hears like an explosion, though, it doesn't necessarily know what's happening, as far as I know. I don't think that it does sort of stuff like that, but that doesn't mean that that's not something you can get. Since GPT-4 is probably the most popular language model right now, at least as of December 8th, 2023, pre-Gemini full release, and whatever the heck happens next year release. I want to use GPT-4 as sort of an idea, and I want this to also abstract out to multimodal ideas, to multimodal agents. So we'll talk about the sense of environment as sort of like linguistic thoughts. Maybe that's not the right way of describing it. I think in thoughts, and when I get in input, I guess let me just start by describing all of the different sources of input which might make up the sense of environment. So we have our audio input. We have our visual input. We have our text-based input. And there are also other senses that I think LLMs will have in terms of like, because there are software, there are sort of like other environmental things like that they have access to that like basically the computer has access to. The computer can understand its own internal state. And this is also probably an important thing to mention is that humans also have a sense of their own environment, of themselves as an environment. So perhaps this is I don't know. Does the sense of environment mean external or internal? And honestly, I think it kind of means both. So I'm going to actually model that out. I'm going to make all of these white, and I'm going to take one of these. I'm going to make it, say, internal environment, environmental brief. That's a good word for it. I think it's sort of a briefing. And then there's the external environmental briefing. And so these are two different briefings, which are basically describing which will be injected into the prompt, which say, here is the state of the internal environment. I am hungry. I need more compute, or the computer is out of storage or something like that. So that's going to affect your internal environment. And then there's the external environment briefing as well. Now, the line between these two, I think, is a little bit blurry, especially for a software system such as an LLM agent or like a software developer agent, because it is paying attention. It's not really paying attention to the outside world in terms of like, the outside world that humans interact with. It's paying attention to the outside world in terms of, the process itself versus the computer that it's on. So I think that the external environmental briefing should be understood. There are two environments to track. The internal is the process itself, the program running the agent. And let me make this a white as well. The external is everything outside of that process. So that could go, like a code base. It's not the process itself, it's outside of the process. So you have to have this idea of like that external environment. So we have the internal environmental briefing, and then we have the external environmental briefing. These are made up of different inputs. So we have our text-based input, and we have our audio, and we have our visual input. And I think all of these are sort of these all kind of make up the external environmental briefing. And because the main input that LLMs get is this linguistic input, text-based input makes sense here. Text-based, I don't think would make sense for human, because we don't get text as input. We get visuals and we get audio as input. We hear language through our visual and audio senses. And all of this kind of culminates in a nervous system, which I think is what the sense of environment kind of is. It sort of mimics the human nervous system, but yeah, I'm just gonna put all of these in the external environmental briefing, and then what I want to talk about here is actually probably a better understanding, a better example of the nervous system. So we have things like state of the process. This could be stuff like memory that it's taking up, CPU, RAM, basically diagnostic information. I'm going to say diagnostic information, actually, because I think that would make sense. I'll be right back. So, diagnostic information is sort of where you get the internal environmental briefing from. That's one aspect of it. So I'll say process diagnostics. Perhaps process output as well. So this is sort of like metadata versus like what is the direct output of the process. Like, is there a bug? Was there a bug reached? You know, like if there was a bug in the process itself, the LLM should be informed of that so that I can make decisions about that. So sort of maybe sub-process output would make more sense. And then like, you know, resource process diagnostics, I think might be better understood as like, you know, debugging information. Sub-process output is sort of like, it could be debugging information, but it's a little bit more broad than that. Resources, information. So this is sort of like, you know, you open up Task Manager and it tells you about all the resource information. Stuff like that is, you know, internal state that should be part of the internal environment and then part of the briefing. And so we're going to basically take all of the internal environment and we're going to, and the external environment, and we are going to make a new one of these. We're going to make this an environment state of the environment briefing. So, yeah, I mean, this is like on many levels of consciousness, this is something that happens. There's some sort of report on the state of the environment, but this is maybe a briefing isn't the best way of describing it. Maybe a report is, but essentially just like here's a breakdown of how things are currently going, and then this is fed to the, you know, sense of environment prompt, which is actually given to the main prompt, which is the sense of perception, which is given to the thought loop. So yeah. Also, one thing that I want to talk about with regards to the memory update mechanism is that we kind of already talked about this, like how this is supposed to work, but so like essentially, yeah, I think I'll actually get rid of this. I don't think that we need a sense of the memory update mechanism as much as understanding that the memory will be updated. That the memory will be updated according to the LLM. So I'll just do this here. I want to bring this sort of like this. LLM decides what memory carries to next step, to next iteration. So part of the response of the LLM will be to say, here's the memory that should actually stay the way that it currently is. And yeah, so, and then the sense of environment should probably be brought down here because I think that this is a little bit cleaner. Let's do that. And so, yeah, the last thing that we probably need to talk about is the state augmentation. So how is the process actually like initiated? And also, I guess I should probably talk about, so what is the sense of environment in a software developer agent? I was thinking about this because I was kind of thinking, like, what is my personal sense of environment? What is the sense of environment that I make my decisions based off of? Sorry, we'll be right back. What is the sense of environment that I make my decisions off of? And what I realize is that my sense of environment comes from the tools that I use. My sense of environment comes from the commands that I run, the space, the environment that I work in. And frankly, we actually have a specific word for this environment, which is the integrated development environment. Now, we can argue over semantics in terms of whether or not like Visual Studio Code and NeoVim should be considered integrated development environments, but it's really just the word integrated that people get hooked on, and I don't think that that's the important part of the conversation. I think that Visual Studio Code, that's what I primarily use, although I do use NeoVim as well, and I'm still not sure which one I prefer. That's a topic for another video altogether. But, so, Visual Studio Code, if I go to Visual Studio Code, let me open up something. Let's go to this one, GPT Developer. So if I open up, this is where I actually plan on implementing this all, by the way. So if I open this up, I have a bunch of different tools. And if I sort of open up my terminal, I also have a sense of the terminal output. If I do, I can run commands in here, I get responses. And I think that this is sort of like what needs to be mimicked by, or this needs to be implemented specifically for an LLM-based agent. And that's kind of the idea that I have, is that there should be some sort of text-based IDE, which it doesn't have to be entirely text-based, but acts as the sense of the development environment for the LLM agent. The environment is how you interact with and make changes to code. And I had an idea based on this as well, not this one, or this one. I haven't completely finished this thought yet, but essentially there are two spaces of an LLM text-based IDE. There's the view space and there's the operation space. And I think that this is kind of how this should be understood. So the view space is when I am looking at VS Code and I have a certain file open. For example, I have my package.json open. I am taking in information. I'm viewing it. And I am, I use this to inform any action that I'm going to take before I take it. I'm not just going to go in blind and start writing code with my eyes closed. It's like I need to take in information. So that is the view space. Then there's the operation space. I actually want to make a change to this file now because I took it in, I understood all of it. I even have a little error here that I can probably get rid of, or that I can, okay, string does not match the pattern of blah, blah, blah. I just took in information, so now I understand what it wants me to do. It wants me to say GPT developer like that. Now it's happy. I made that change in the operation space after viewing it in the view space. And so when I think of how a text-based IDE, or an IDE specifically for an autonomous software engineer, which has a reasoning engine in an LLM, or even in a visual way, this is sort of where this idea of the view space emerges. Now, what are some aspects? What are some actual implementable materials within the view space? Well, the first one is the viewable area of a current file, complete with 9 line numbers and symbolic metadata from the language server. So, like, if I go back over to package.json, I want to maybe go to a specific package. Let's go to an app, and let's go to the agent, and let's go to the CLI. This is all from AutoGPT, by the way, and I haven't actually gotten much of this. But, okay, so I'm getting language server and linting information in here. I have line numbers. I can see just this part of the file. I can't see the entire thing at once, and I think that that's an important aspect. Like, my focus is here. So, like, I have this error, I have this one. If I want to see language server information about, like, the system, the os.system function, then I can do that. It gives me language server information. And so I think all of this stuff is like, what the actual, like, view space of the LLM should be. So because of that, the view space of the LLM is going to be made up of that part of the file, as well as the file tree, the command console output, and the application output. And there are probably other things as well. But say so whatever happens in the operation space will affect the view space as well, and vice versa. So it's sort of this loop between the two. The view space is given to the LLM. So the LLM makes an operation in the operation space, and then the operation space changes the environment, and so the view space, reflection of the environment, is fed to the LLM, which then sees, okay, that's what my operation from the operation space did. So this idea of the operation space and the view space is kind of one that I think is important to understand how these things will actually work. So in the operation space, you might have things like running console commands. Outside of running console commands, you might also have like editing files. There are a few other things that I had in here as well. If I go and I look at Junior GPT, I think I have, version control information. There are some operations in here which, like, changing version, managing version control systems, stuff like that. Basically, the operation space is when you're actually making the changes and influencing the environment, and then the view space is when you're actually reading it. And so if I go back over to our chart over here, the sense of environment is the view space, and the state augmentation is the operation space. So these two kind of are the generic versions, but when we're talking about a software developer agent, it can be that specific implementation of the view space and the operation space of a text-based IDE. And so that's kind of what I'm working on over here in my Quasar Brains organization, is this idea of both the agent itself, which is going to be like the thing that can actually utilize tools, and then the IDE, which is sort of the sense of environment and operation space. So yeah, that's kind of what that is. Now, if we want to talk about state augmentation a little bit more specifically, and we kind of want to talk about like and how this should be implemented, we can kind of talk about it like this is like your toolbox in some ways, or it's like, your arms or your fingers and how you like make changes to the world around you. It could be a keyboard, just like tools, basically extensions of yourself which allow you to enact your will on the environment. So I'll actually say that extensions of the self which allow you to enact your will on the environment. And I actually might not want to say self in that matter, because I think that might be just like a little bit not a good description. Extensions of the self which allow you to enact your will on the environment. And because of that, what does that look like in software? Oftentimes in software, that looks like making calls to REST APIs, doing a web search. When we're talking about AI agents, you usually can actually just give your agent a list of tools that it's able to use, and then use this to solve your problems. So that's kind of what this whole idea is of state augmentation, is actually how do you get the agent to actually use the state augmentation tools available to it. So let's kind of talk about what different types of tools there might be. And I mean, at the end of the day, it's just kind of like this exists in some function space where you can call a function that actually performs something. Now, what I will say is that there is there's state augmentation, and then there's sort of there's this idea of pure functions. So functions might not be the best way necessarily to say it, but there is well, I guess it could work. So there's functions with side effects, and then there's functions without side effects. I'm not sure if that really applies here. I'm not really sure how. I think, okay, so maybe one taxonomy for this is to say that there is a toolbox, and then there is how you actually pick from the toolbox and then use that. So then so there's the toolbox, and then there's the executive aspect of state augmentation. So toolbox is sort of like the potential augmentation that you can make, and then executive is sort of like the actual thing that is performed, that is executed. So these are sort of two stages. Toolbox has potential list of potential existing tools. So these are what are all the things that you could use? What just give me a big fat list of all the things that you could use. This could also be ability to create new tools. So basically this is the potential space, and then this is the actual kinetic space. This is where that's actually put to use. So this is using a specific tool, you making a new tool and then using it, maybe. I feel like this might be the simplest part of the program, and I might just be trying to make it as complicated as the rest of these things. It's pretty simple, I think. Just give it the ability to make a new tool or use an existing tool, and then give it some sort of parameters, and then transform it into the executive, and then use that. So toolbox is the potential, executive is the actual execution of that, and then it can sort of put parameters into it. Now that being said, that might be a good way of saying it, ability to create a new tool. Excuse me. So the executive is the actual execution. The executive requires taking from the toolbox and enforcing some sort of parameter. So let's just say parametric execution or something like that. We are executing this. Discriminatory. Picks and adds parameters and inputs arguments. So I'm imagining this like a function where you have a big list of functions to choose from. You pick one and then you give it an argument. And this would be kind of the same as you take a hammer out of the toolbox and you swing it at a certain thing. It's you can't just, you have to have some sort of decision-making process controlling how exactly this function is or tool is utilized. And so that's kind of how I think this needs to work, is like there's this aspect of taking it out and then imposing your will on it by controlling it in a certain way, giving it certain arguments. And if you're talking about like a function, and or when you're making a REST API, like giving it, or when you're making a REST API call, just like giving it some sort of uh, like like parameters essentially, and then that makes it do something specific. Maybe you need weather information, and so you kind of give it this. You make a call to the weather API for a specific location, and then it gives you information about that. So that's kind of why I think this is important. Maybe so picks and inputs arguments from the toolbox, and then executes, and then that actually that goes through some layer, which actually potential executive potential. So, okay, toolbox. So there's sort of this toolbox potential, and then now there's an executive potential. You have constructed some sort of function with arguments that can now be actually executed. And so then I'll say that there's some sort of execution layer. So let's copy this, bring that up here. Real execution. And then the output of that real execution is what's given to the prompt. So let's take the state, and assumedly the real execution should affect the environment which is being monitored by the sense of environment. And that's so you don't necessarily need to take the output of the function specifically and give that to the real execution and give that to the LLM every time. You can just make that output be the state of the environment itself. When the execution, when the state is augmented, it will affect the sense of environment, which will be injected into the prompt again. So yeah, essentially like there will be some console window or something which maybe displays an error message, but if your edit really works the way that it should work, then you're going to get then the file itself is going to be edited. So yeah, I think that's kind of the way to understand state augmentations. Extension of yourself, which allows you to enact your will on the environment. Toolbox is all of the potential that you have to enact said will. You can pick a tool at discretion and form a plan on how to use it effectively. Then you can put that plan into action and augment the state. This augmentation, the state will then be fed to the process before. So yeah, I mean, this is also like, I think we have to think about, I brought this all the way down here. This is sort of like an overarching idea, so I'll bring it back up there. But this is sort of like, you have this idea of the working memory. I think that the state augmentation kind of needs to be put into there needs to be some memory mechanism. What did I just do, and how did that actually change the state of the augmentation? I think that the difference between the previous state across multiple layers should be understood. Like, what are all of the changes that I just made, and what's the current state of things, and then like what's my goal, stuff like that. So I think that some sort of this state augmentation needs to be put into memory. okay, so LLM decides which memory, and then, so the working memory also is informed by, okay, learn something new, and then what steps have been taken already within a certain window. So, yeah, I guess I should just probably update that. But, yeah, so I think that this is kind of, I mean, did I get all of the ideas? Yeah, that's 4. So, yeah, I mean, that's really how all of this will work, I think. And now with the state augmentation, like we were talking about, this is the operation space. These are the actual developer operations which are taken by an individual developer in order to achieve their goal. So like when I'm writing code, I'm editing things. I'm executing commands. I'm running commands and such. And then that affects the environment. So then my sense of the environment will notice that effect. And then my memory will remember what the environment was before. And so I'll understand actually how the operation that I just made affected the state of the environment. And then my agency informs whether or not that's a good thing, essentially. And so there's this sort of iterative process which allows this actually all to happen. And so I think that, like, with regards, because this is also about, the future of AI developers and autonomous development generally, I think what I really want to highlight here is, like, all of this stuff is in place. All of this can be done. We have all of the tools that we need for memory. We have all of the tools that we need to give the LLM a sense of environment. We have an LLM which can actually reason now, and that's been the big piece which didn't exist before. All of the rest of this existed, but the LLM, the reasoning engine, which that's just completely new. We've never had something which could actually make informed decisions and actually do something productive in terms of thinking. There's some sort of thinking which exists now automatically in a tool that never existed before. So all of the tools are in place. Now, the quality of that thinking isn't on a human level yet, and that's important to understand. But at the same time, maybe 3 of them together, 3 agents might be as good as, 1 agent. I think that there is some sort of level of diminishing returns. Stuff starts to get lost in the communication. Stuff starts to get lost in the understanding of complex concepts. Stuff starts to get lost. Maybe in order to get to 100% of the productivity of a good developer, maybe you can't just keep adding on new developer agents. Maybe there's a diminishing return and it's some sort of logarithmic function where you'll never actually reach that 100%. But you plateau somewhere and then, it just kind of doesn't actually get any better until we see a real breakthrough in the fundamental reasoning of the LLM. Perhaps that's the case. Whatever the case, I think we can get to at least 75, and obviously these aren't exact numbers, because, how could you make an exact number here? But, except for, I guess we have benchmarks and stuff, but basically what I'm saying is, I think we're at, 75 to 80% of the abilities of an average or even good software developer to build certain things and to actually make things happen. I think all of that could be done by an LLM if it was given the right tools. And obviously a lot of people are working on this problem. But with regards to the future of autonomous software development, the future isn't that far away. It's probably here in the next year or so, if that. It already exists in a lot of ways. Our entire way of writing code is different than it was 2 years ago because we have Copilot tools which complete our code that we write. Everything is completion based now, and when I am writing code, I'm also talking to ChatGPT in one window, which is telling me, instead of looking up, an error message and spending an hour on some error that I find, it's solved in 10 minutes at most because I can just keep giving ChatGPT, well, here's the output of the last thing that you had me try, and, here's the new error. Well, that's probably because of this. Run this command, and then there you go. Same thing I was doing with Stack Overflow before, but now I don't have to do all of that reasoning. And I mean, like, obviously, I'm not saying that because I think that that's like how people should do things. I'm not saying that to because I think like there is no downside to that. Obviously there is, and you should still be practicing like problem solving and debugging and things like that, but it just kind of goes to show the state of AI applications right now are already powerful enough to significantly change the way that humans do software development. And I think that in a lot of ways they are doing that. They are changing things. And that isn't going away and is only going to get more capable. All of the tools are in place. And so, yeah, that's what I'm going to try to build. I'm going to try to build something that automates my job as a software developer. I think that that'll be really cool. I think it'll be really scary, obviously. Like I said in the last video, none of this can be taken lightly. This is people's jobs. This is a lot of people's jobs. This is a lot of people's livelihoods. A lot of, even the software that doesn't exist yet that could automate out some person, like that is going to change here too. I mean, this is even like, AI development itself could be done in large parts by large language model based agents. And so like, yeah. But I also think that that's a really good thing because right now it's all done in proprietary ways by large groups of researchers where the open source community doesn't have the same access to resources. There's not the same like infrastructure in place. But if we can, drastically reduce the cost of doing that kind of work by building LLMs, even if they can only reach 80% of the effective ability of a human software developer or software engineer, that's fine. Because that's what the software engineer will do then, the 20%. 80% of the job is done by an AI, and the 80%, or in the 20% is done by the engineer who needs to be able to control that AI. And so in a lot of ways, the engineer is still 100% is crucial to the survival of that specific job. Like that specific job isn't going to be automated until 100% can be automated, especially for mission critical applications where like you can't really, like you need to be able to have somebody who can do 100% of the job, not just 80% of it. And it also goes to like, server administration. Like I can also see a lot of potential for bloat. Like you think you have a lot of front end frameworks now. Like what's it going to be like once an AI can pump out a new front end framework in a couple hours? Like, yeah, it has a lot of implications. I want to talk about. I might make a part 3 of this, but I think that this was a little bit more of like a technical little series, so maybe I'll call it here and then make a new like little video talking more specifically about like what developer jobs will look like in a year or two, because I would like to figure that out as a developer myself. But that's some of my thoughts. I think it's going to change a lot. I think all the pieces are in place. I'm going to try to build this like right now. Like this is my biggest goal at the moment, is just like taking this chart and making it into some sort of reality for software development specifically. I may use AutoGPT as a template, but I'm also thinking I want to build this all from scratch. I think that that's going to be required because there are AutoGPT based code changing, like code developer tools, which I need to use in order to understand like what the current state of things is, but they aren't perfect. I think that I need to really build it from scratch in order to understand every little piece of how it should all work, and that is going to take more time, but yeah, that's what I'm going to do. So thank you all for watching. If you did, I would be very surprised, but thank you for being here, and I will end the video there.